7.3 hyperbolas. So here is a picture of our hyperbolas opening right and left. So you'll notice you have a center. Oops, here we go. Let me change it to an arrow. So you've got your center, and you're going to kind of do the same thing you did on the ellipses. You're going to go out A, left and right, and since the B is underneath Y, you're going to go up and down. They usually leave the A underneath the positive one. As long as this is your positive fraction, it's going to open up right and left. On the next screen, when we switch it and your Y is positive and your X is negative, it'll open up and down. So whichever fraction has a positive sign in front of it, that's the direction that it opens. You still have a center of HK, so this just looks like the ellipses. The only difference is you want your foci, your two focus points, your foci to go out farther. So in order for them to go out farther, you're going to have to add them together. The other thing on here for your asymptotes, you're basically going to take your numerator here. So for your asymptotes, let me change my pen width. You're going to take the y minus k part, plus or minus, because you're doing point slope form. You need to do your slope then, so you need to do rise over run. So you're going to go up B over A. So in this case, it's B over A times the x part. This should look reminiscent of your point slope form, and you'll use that a lot in calculus. Now you'll notice that you're going up and down, and so this time your y fraction is positive, your x is negative, and you're going up and down. The A is still with the one that's positive. I wouldn't worry too much about the A's and the B's, just worry about which one it's underneath. So you're going to go up A to the right and left B. Oh, and the other thing I forgot to go over on the last on the last screen is that the axis that goes through your two vertices, that's called your transverse axis, and the other one is your conjugate axis. This box is not really part of your graph, but it helps you to put your asymptotes in here instead, and it will help you know how wide or how skinny to make them. And your foci now go up and down. Your foci is still a squared plus b squared. And again, your asymptotes, you're still going to do the y part, equals plus or minus, but this time you're going up A over B. Really, I would just remember on your graph to do rise over run. So that way you don't get bogged down in the A's and B's, and then times the x minus h part. And again, it should look similar to point slope form. And yes, you need to memorize that. Okay, number 1, I have x plus 5 squared over 4 minus y minus 4 squared over 9 equals 1. So we're going to do the same thing that we did on the ellipses. My center is going to be, oh, I didn't mean to do that. My center is going to be negative 5, comma 4. So negative 5, comma 4. I'm going to go square root of 4 means we're going to go out 2 to the right, 2 to the left, and then up 3, down 3. And instead of making an ellipse, you make a little box. I'll try to stay on the lines. It's a little hard for me on my iPad to stay on the lines, but try to stay on the lines. You're going to draw asymptotes through the corners. And since this has a positive x plus 5 squared, my hyperbola branches are going to open right and left. So these are my vertices. And so I went right and left 2, which means the x is going to change. So if I add 2, I'm going to get negative 3. If I subtract 2, I'm going to get negative 7. So without even really going on your graph to find them, think about which one you're adding and subtracting things to. My foci, you do by adding your two denominators. 4 plus 9 gives me 13. So my c is square root of 13. So square root of 13 is between 3 and 4. Because it's between square root of 9 and square root of 16. Yes, you're going to have to do that without a calculator on the test. So 1, 2, 3, between 3 and 4. 1, 2, 3. There's my two foci. And if I went right and left square root of 13, that's going to make my point -5 plus or minus square root of 13, comma 4. My asymptotes, take the y part, plus or minus, and then I have to do rise over run. So from here, from basically just do the rise over run of the box. So I'm going up 3 over 2, so my slope is 3/2, and then take the x part. Remember not to take any of the squares because this is the equation of a line. Eccentricity, again, is your distance from your center to your focus divided by center to your vertex. So my center to my focus was square root of 13, divided by center to my vertex was 2. Center to focus over your center to your vertex. And you'll notice that this number now is bigger than 1. So keep in mind that on an ellipse, your eccentricity is less than 1. And on a hyperbola, your eccentricity ends up being greater than 1. Okay, so on 2, we're going to have to complete our square first. So we're going to regroup 4y squared minus 48y. Leave a space, minus x squared plus 2x. Move over my 127. Then the next step is we need to factor out a 4. That's y squared minus 12y. Here, this is something new. You're going to have to take out this negative, which means if I take out a negative, I'm going to have to take a negative, out of my 2x as well. Don't forget that, or it's going to mess up your whole entire problem. And all of your points, your graph, everything will be off. Then you're going to take the -12, divide by 2, square it. Gives me -6 squared, which is 36. But what you need to add to the other side, remember, is the 4 times the 36, which is 144. You need to multiply these two together. That's a really bad multiply. Let's try writing that again. Multiply. And then -2 divided by 2 squared is 1, but I need to add -1 to this side. So that gives me 4. This factors 2y minus 6 squared. This factors 2x minus 1 squared. -127, 144, and minus 1 gives me to 16. Last step is divide everything by 16. That gives me y minus 6 squared. 4 goes into 16 4 times. Minus x minus 1 squared over 16 equals 1. So I'm going to rewrite this on the next page. So you might want to pause it now if you haven't gotten it all copied. So our equation from the last slide, hold on, let me shrink this a little. Oh, let's erase this. Let's shrink this a little. Okay. So my equation from my last slide was y minus 6 squared over 4 minus x minus 1 squared over 16, that's squared, equals 1. So my center from this is 1, 6. So 1, 6. My vertices, I'm going to go out to right, to left. Oops. Let me do that again. I'm going to go 2 up. The square root of 4 is underneath the y. We're going to go 2 up, 2 down. Square root of 16 is 4, so I'm going to go 4 right, 1, 2, 4 left. Make a box. And I'm going to put asymptotes through the corners. And since this y squared is positive, I'm going to open up and down. Okay, then my vertices are these 2 points here, 1, 8 and 1, 4. 1, 8, 1, 4. My foci, 4 plus 16, you just add the two denominators, gives me 20. C equals square root of 20, which is square root of 4 times 5. Square root of 4 is 2. So 2 root 5 is between 4 and 5 between square root of 16 and square root of 20. So I'm going to go up and down about 4 and a little more. Oops, not 20, it's 25. So I'm going to go up 1, 2, 3, 4 and a little more. Down 1, 2, 3, 4 and a little more. And then we're going up and down, so we're adding to the y. So that is 1 comma 6 plus or minus 2 root 5. My asymptotes, I'm going to take the y part, equals plus or minus, because, that's ugly, equals plus or minus. I have 2 positive slopes, that's why, or I mean, sorry, not 2 positive slopes. I have a positive slope and a negative slope, that's why you put the plus or minus. Then I went up 2 over 4, so that means my slope is a half, x minus 1. And then my eccentricity is my distance to my focus divided by my distance to my vertex, which gives me square root of 5 for my eccentricity.